All right, everybody, thank you. Please take your seats. I'd like to introduce Muffy Barkocy with Instacart, who will be talking to us about Terraform and RDS.
Hopefully we've worked out all the technical difficulties I was running into. I'm told, because this is the first talk I've ever given outside of work, that when you're giving a talk, you should tell people what you're going to tell them, tell it to them, and then tell them what you told them. So what I'm going to tell you is what RDS and Terraform are, who I am, and how I got a lot of experience with both of them. Then I'm going to spend a pretty long time telling you how much it sucks to use Terraform with RDS. But finally, I'm going to say you ought to do it anyway. So here we go. So first of all, what's RDS? Amazon's relational database service. So it's just their wrapper, their service wrapper around whatever relational database you want to use. They have their own called Aurora. They support MySQL. They support Postgres. They support MariaDB, a couple others. But we've always used Postgres at Instacart. And the problem with RDS, and it's the first of the problems in using Terraform with RDS, is that RDS itself is an abstraction layer. So you don't get to see the server, you don't get to install the software or recompile it if you want to, build in some other packages. AWS handles all of that, which is great most of the time because they're going to take care of the machines and provisioning whatever hardware you need. They're going to add the disk, they're going to install the software, they're going to install updates for you, they'll do backups. All of that's great until you actually need to look at the machine or look at the logs to figure out a problem, and then you have no access to it, and you're submitting support tickets and getting answers back from AWS, and that's a really difficult way to debug things. I think I've gone one too far. Hold on. Yes. So what is Terraform? Right about the time I started using Terraform, I also started playing like the most amazing board game ever, Terraforming Mars, which you see on top there. If you like board games and you haven't played it, you should. It's number 3 on BGG. And what terraforming is, in that sense, is the process of taking an environment which is not hospitable to human life and making it hospitable to human life. I don't know. I looked for the origin story and couldn't find it, but my guess is that that's why they called Terraform that, because it does make life as an infrastructure person a lot easier. It makes it a lot easier to manage your resources. In particular, Terraform is what they call infrastructure as code. And it's also a provisioner, so it's a little bit more than just the code to describe your infrastructure. It also creates your infrastructure. And it's another abstraction layer. So you're describing something that is a real thing in the real world, but you're describing it in this HCL, which is HashiCorp configuration language, which is the way that the company HashiCorp, who made Terraform, have made their DSL for this. And then finally, it's not at all agnostic. So it says, okay, yeah, you can provision any resources you want, but you have to use a different provider for each set of resources you want. So there's a provider for AWS, there's a provider for Google Cloud, there's a provider for Azure, the provider for many other things. GitHub has a provider. You can't just port one from the other. You can't change the name from like AWS DB instance to Azure DB instance and everything works, because each of those services has different things that they require to be defined in order to create the resources. So we're talking, in the end, Terraform is talking to their API. And whatever their API needs, Terraform provider has to provide. So each provider is distinct. However, I think you can imagine once you've written this all down and you say, okay, this is how I create my database, then you could translate that or port it to another provider if you wanted to. So from a code standpoint, it's pretty straightforward. Actually doing that would be, I think, a nightmare, and I can't really even imagine trying, but some people talk about it sometimes at my office, and I'm just like, no, don't do it. So why infrastructure as code? I've talked about that already a bit, but well, first thing, everybody's doing it. It's the big new thing in DevOps, which is not always a good reason, but in this case, a lot of really smart people are doing it, and they have, you can go out and read about why this is a really good idea. But pretty simply, when you treat things as code, probably all of you have developed code before, and it gives you a couple things. One thing that it gives you is that it's descriptive. So code, if you're writing code for anything, it's really a representation of the real world things that you're interacting with. And so this is the same way. It gives you a way to write down everything that you have in your infrastructure. And if you don't have that, what do you usually have? You have some architecture diagrams, and then for a while somebody's updating those diagrams, and then after a while they stop updating those diagrams. And then somebody says, what resources are we using on AWS? And you're like, yeah, I don't know. I mean, I have this diagram from 2 years ago, and that's probably pretty accurate. But with Terraform, you've actually got everything written down, and so you can say, this is exactly what I've got. And I mean, it's not easy to read, just like any large code base is not easy to read, but it is there, and it is therefore susceptible to all of the same things that you can do with source code. You can have source code control. You can have a release process. You can have reviews. You can have different developers working together on the same pieces of code. That would all be really difficult if you were just going into the AWS console and working on these things. Particularly working on them together would be very difficult. And hopefully I don't have to explain the benefits of source code control generally. Let's see, where did we end up now? Going backwards. Okay, so who am I? And why am I giving this talk? So I started software development. Well, I really started when I started college, so 1981, but I got my degree in 87 and started working for a company that made natural language interfaces to relational databases. The relational databases at that time were Informix, Ingress, Oracle. Postgres was still under development over at UCB at that time. As it happens, I knew one of the guys on the team, but I didn't really know that Postgres was a thing. And I went through my career. After that, I actually went to work at Informix. Then I started working on websites in the mid-90s. And by the time we got to 2015, I went to work for Instacart, and I had kind of given up on working on UIs. I started out on UIs. When I got into web work, I developed some websites. I was a sucky designer, like we all were. I mean, this was the mid-90s. So I'd been moving further and further to the back end. So by the time I got to Instacart, I was really working very heavily on the back end. I went to work for the orders team. And the orders team, as you might guess, is for writing down orders. So we would record those in the database. And at that time, we had only two major Postgres instances, one for our catalog and one for our customers. And we were very rapidly running out of space in the customers. So one of the things that AWS RDS does is it gives you a limit on how much space you can actually have in the database. And the limit there was 4 terabytes. And we were, when this came to my attention, we were about 3 months from running out of space. So we had a little graph, and it was edging up towards the line, and we were going to be blowing out that space. So we made a cross-functional team with the infrastructure team and with my team, because we were using up most of the space, to try to figure out a way to transition to a larger database, something with more space, and we weren't really sure what, but we tried several different options. But the thing that was important was not so much the size, but we needed to do it with very little downtime. Because 4 terabytes, if y'all have done it, migrated something of that size, it could take days potentially, because something always goes wrong and you have to start again, and it takes that long to dump the data anyway. And we couldn't afford days of downtime. We could afford maybe a couple hours of downtime. So we're trying to come up with a solution that would give us minimal downtime and allow us to transition to some other solution, whether it was a hosted Postgres by some other place, our own hosted on AWS, or at that point they were just releasing AWS Postgres Aurora. And so Aurora is their internal version, which supposedly is infinitely scalable. We have not yet tried it, so I won't comment, but it sounds really good. So anyway, we worked on this for about 6 months, and in the process, we did table partitioning, we did some removal of data that wasn't really necessary. We split the databases a couple times so that we had more specific data stores for different purposes. But we never did figure out how to transition with minimal downtime. And fortunately, about the time we were ready to blow out the database again, even with all the improvements that we'd done, Amazon said, oh, hey, now you can have 16 terabytes. And we're like, great, saved. And I swear that Amazon is just like sitting in our conference room waiting until we're just completely desperate. And then they're like, yes, we will give you more space. So after that, I joined the infrastructure team. I really enjoyed working with them, and it's an area that I hadn't really been too deeply into before. I'd done some system stuff at some small companies, but nothing at the scale of Instacart. So I joined the team, and the first project I was given was to start getting our resources, all of our resources, into Terraform. So the team had started about a year previously, in early 2017, to start putting some of our resources into Terraform, but all of them were not in there. And one of the first things they gave me to do was to terraform all of the RDS instances. Now, unfortunately, our team had very little experience with Terraform. I had zero experience with Terraform, so I ended up copying a lot of the mistakes they'd made, making some of my own, and then really starting to learn it. But I made a real mess of the early Terraform, which gave me a lot of experience in problems that you can run into when you do it badly, when you make mistakes. Again, very much like learning any new language, you have these problems. But I started to straighten it out. I've been working on it for 2 years now, and we've got almost all of our resources in Terraform. So I counted, before I was doing this talk, we have about 15,000 resources, AWS resources, configured in Terraform. That's in 280 stacks, and a stack is like a single system, so any related resources that might support a particular service or whatever you're doing. We have in there, and again, this is at the time I made these slides, I think we have more now, but 34 distinct RDS instances. So those are core to one of our services, with 29 replicas. So we make read replicas. Sometimes some of those databases have multiple read replicas, others have none. I think the most we have is like 5 read replicas on one of the RDS instances. So that depends on the usage of the database. And then we started working at the beginning of last year on this multi-environment project. So what that is, and I think this is probably the coolest thing about Terraform, it's certainly one of the reasons I would recommend it, that is our ability to take what we have configured in production and make a fairly exact copy of it in another environment, so a different account, completely different resources. And the important thing about that is that previously, I've worked at places so many times where it's like we need a realistic staging environment. It has to match production. But it never really matches production. And again, just like I was talking about before with code drift, you know, people make changes, so you have your nice architecture diagram and you replicate that into staging, and then you make changes in production and you replicate a few of them to staging, but not all of them. And then you want to set up a development environment, so then you make another bad copy, and it's like ancient Xerox machines that are just not doing a very good job. And so then you end up still having to test everything in production, because that's the only environment that actually looks like production. Okay, so let's look at Terraform itself now. So on the left is the Terraform to create a database, and on the right is the output of Terraform plan. So there are two really important commands. There's several important commands in Terraform. One is plan, and the other is apply. So when you do Terraform plan, it's going to take that HCL that you see on the left, and it's going to decide how it's going to turn that into actual resources in AWS and spit out this plan. And the plan shows you exactly what it's going to provision. So in this case, you'll see that I've specified like 10 parameters here. And on the right, we've got maybe 30. And the reason for that is that AWS obviously allows you to specify more than what I've specified. So either the Terraform provider, which is a piece of code that somebody wrote, probably someone at HashiCorp, but maybe not, you can write your own, they've decided what that value is going to be. So in that case, you'll see the value on the right. But there are a lot of values there that are marked known after apply. And what those are the defaults that AWS is going to have. And the provider doesn't assume that it knows what AWS is going to do, because the provider might keep going while Amazon makes changes, and you don't want to have to keep those in sync all the time. So it's showing you everything it knows at this time about what it can do when it's creating this database. So then we go to the next thing, which is to do Terraform apply. And in Terraform apply, it makes the API calls necessary to do whatever it is you asked it to do. So it's actually creating the RDS instance. Now this isn't enough to make like a usable RDS instance. We don't have security groups, we don't have any sort of access. We need to obviously set up the schemas and all of that. But what it will do is actually create an RDS instance, and you go to the AWS console after it says it's done, and you'll see your database. There it is. And if you create other things in your Terraform, a plan can have as many things in it as you want. I've seen 30 or 40 things, but just as with any code change, that is usually excessive. You usually want to do things in smaller bites if you can. But I'm just going to talk about databases specifically here. So then this one took about 3 minutes to provision, and it would just spit out a status every so often. Our databases mostly take like 30 to 40 minutes, and I'll often get developers pinging me after they start an apply, and they're like, why isn't my database there yet? I'm like, look, it takes about 40 minutes. A lot of that is just due to the sheer size, but also due to the fact that we're actually running it through an additional system called Atlantis, which lets them do it from GitHub, which is pretty cool, but I'm not going to go into details on that now. Okay, so you want to then do a change. You want to make a change. So you're like, oh, that was a really tiny database. I need a really big database. So you increase the storage. You give it a bigger instance class, which is going to be more memory, more CPU. And you do Terraform plan again. And you'll see that I've marked a second thing here, apply immediately, which I'll talk about. But you see the changes have the little tilde before them. So it's changing the allocated storage. It's changing the instance class. And in addition, you can see all the values that got set automatically. So values that I did not set, but that AWS set, or that the provider set. So when it shows you the plan, it shows you what is actually already there, all of it, and then it shows you the parts it's going to change, or add, or delete. And then you run Terraform apply, and it takes 33 seconds. And you look at that, and you're like, well, that's pretty fast to allocate another, a terabyte of storage. That seems like a lot. Well, what's going on here, let me go back a second, is that there's this apply immediately parameter, and that makes a difference in terms of how it applies. So if you have apply immediately set to false, then it will not actually restart the database. So it'll make any changes that it can make which don't require a restart of the instance. But it will not make any changes that do require a restart. So if that's set to false, then it's going to apply very quickly, but it's actually not going to make all of the changes. So if you then go ahead and do another plan, it's going to say that it's going to make the exact same changes that it had told you it had already made when you did an apply, and it said, sure, apply complete. And the reason for that is that the plan is showing you what is actually in the remote system and what your plan would change. It's not showing you things which would happen later. So in order to make something happen right away, you need to set apply immediately. But what that means is you could end up rebooting your database. So if this is like your production database and systems are busy talking to it, you set apply immediately to false, and then you set a maintenance window, and during that time you reboot the database, and then you'll get your changes. Okay, so very quickly, you can also tear stuff down just as easily with Terraform destroy. And really the only thing that happens is it says, do you really want to destroy all these things? And you say yes, and it starts tearing everything down. So one thing that's really important is to make sure that not everyone has permissions to do that, whether you restrict them based on specific operations, or whether, as we do, you actually don't allow most of your users to do Terraform apply. Mostly we restrict that to the infrastructure team, so engineers can request that we make updates to the infrastructure, but we have to approve it and apply it. And I think, that's one of the both pro and con for Terraform is that it's so powerful. I mean, it can really do anything that you give the Terraform user permissions to do, and because you want to use it to manage your infrastructure, you generally give it administrator-type permissions. So far I've been like, this doesn't seem so bad, right? I mean, I think if you've had experience with this before, you can see some drawbacks to something so powerful, some drawbacks to things that are abstracting away what's actually going on underneath. But where it gets more painful is parameter groups. And this is actually an abstraction on the Postgres configuration. So normally you'd set these variables using POSTGRESQL.conf or or even in SQL or on the command line when you're starting it. But the way AWS handles that, because they're doing all the server management, is that they have this additional resource called a parameter group. And so on the side here, these are just some of the parameters, obviously. This is what you'd see in the AWS console. And the source shows you the source where the value came from. So there's a couple of these that are set to user because we set them in the original Terraform that we applied. Others are engine default, which would be Postgres default, or their system, which is going to be AWS's defaults. And then they have an apply type, and this becomes really relevant. It again has to do with that apply immediately. So if the apply type is dynamic, that means you can update it while the server is still running. And if it's static, then you're going to need to restart the server in order to make that change. And y'all are pretty familiar with Postgres, so you probably know a lot about these parameters and which ones can and can't be applied immediately. But other than looking at this column in the parameter group, AWS doesn't really tell you, and it doesn't warn you. You can go ahead and update the value, and it'll say, yeah, I've updated it. So let's take a look at that. So sorry. So first of all, one thing more about parameter groups is they are reusable. Because it's a separate resource from the database, you can reuse it for another database. And that's really convenient, like if you have multiple replicas and you want them all to be configured the same, or certain replicas the same and certain different. Okay, so if you want to, the other thing that's cool about Terraform is that it has this implied dependency between the parameter group and the database, assuming that you format your Terraform correctly. So in this case, on the top here, you say the parameter group name is set to AWS DB parameter group, which is the resource that you've defined, and then the name of it, which I've set to Muffy PG, and then .name, which is an attribute of that. So that tells Terraform, that lets Terraform create a dependency graph between objects. So it's going to say, okay, this database depends on this parameter group, so I'm going to need to create the parameter group first, and then I'll create the database. Now you can also define it the way I've done below, where you just say the parameter group name is the name of the parameter group. And that will work, but then there's no relationship defined between the two. So Terraform also lets you define these interdependencies between elements of your infrastructure. And other things you can specify on a database are things like a security group or what VPC to use. And again, each time that you use these references to other resources, it will say, okay, that other resource needs to exist before I can create this resource, and it will order them that way. So that is another thing which this infrastructure as code gives you, is it shows relationships and what things are used by other things. Now, one of the things that we found, which was a bit of a surprise, is if you want to change something significant in a parameter group, it's going to try to delete it and recreate it. So sometimes it can just modify it, and other times it wants to delete and recreate it. But AWS is going to object to that, and Terraform is not. So you'll change the database family from Postgres 10 to Postgres 11, and you're like, great, now I've updated my parameter group to Postgres 11, and you think it's a separate resource, so it should be fine, right? Like, I can just update this separate resource and nothing bad will happen. But Terraform is not sure that it can update that value in place. So it says, okay, I'm going to destroy the old one and create a new one. And then AWS objects, and it says you can't delete a parameter group that's still in use. So when you want to make significant changes to the parameter group, you need to create an entirely new parameter group. And that leads into a story I'll be going over soon about some real trouble we had with these. But now the apply method. So this is very similar to apply immediately on the database. The apply method can either be immediate or pending reboot for a parameter. And if it's immediate, it will go ahead and make that change. So these are these dynamic parameters that you can set, just like you could just like go into PSQL and you could set the value of the parameter there. So in this case, I'm going to update the auto vacuum nap time, and I do the plan, and I see the change, and the change here is displayed as I'm adding a new parameter and I'm deleting an old parameter. And that's not a great display, because if you've actually set like 20, 30 parameters, it doesn't put them together. It just puts them kind of, as far as I can tell, randomly. I've tried to figure out an ordering, but I haven't been able to see it. So you'll have like a deletion up here and an addition down there, and it's very difficult in that case to see what you've actually changed. So this is one of the real pain points, is dealing with parameter groups when you're wanting to make updates to your database. And it's much more difficult than just kind of, hitting the console or hitting the editor with the PostgreSQL conf file because the diffs do not show in a really readable way. So I spend a lot of time like in an editor going back and forth between the diffs to make sure that they're really what I want them to be. So we go ahead and apply that change, and if you look in the AWS console, first it will say modifying on the database, it'll say it's applying the parameter group, and then it'll say it's in sync. So great, we've updated our parameter value, and if you went and looked at the parameter value in the database, you would see that it had been updated. If it's a pending reboot parameter, you do the same thing, you get the same plan, you go ahead and do the apply, and it will tell you that the apply succeeded because it did. It has updated the parameter group. What it has not updated is the database. So the configuration of your Postgres server is still whatever it was before you did the apply, because this is a parameter which only gets applied on reboot. So you have to then go into the console, and you can see that it's pending reboot. So it'll tell you that it's not in sync, but you have to look. Terraform doesn't tell you. Terraform's just like, all done. And then you have to actually reboot your instance to get the change. And that was something that was not terribly clear, but it became even less clear when I found out that if you mix values, so if you set a parameter which is immediate to pending reboot, or a parameter which is pending reboot to immediate, you get weird behavior. So if we set it to immediate when it's really pending reboot, it's going to go ahead and plan it, and it's going to go ahead and apply it. It's not going to give you an error until Amazon complains and says you can't update that parameter because it's a static parameter and you're trying to update it dynamically. So you go all the way through the plan and apply process, and if you're doing it through source code control, also the pull request and approval and everything, and then it says, nope, you can't do that. Then you're like, okay, here we go, back to step one. Back one. And so if you do it the opposite way, you will have set it to pending reboot, and it will just go ahead and apply it because it's dynamic. It's fine. It can apply it now. So now, if you think pending reboot means something, it doesn't. If you set it on an immediate parameter, it goes ahead and sets it. So in these cases where you don't know which one, maybe you haven't gone to the trouble of looking up and seeing if it's dynamic or not, you can think you've specified one thing, and you can really end up specifying completely the opposite because it ignores what you specify. But if you don't specify it, it's always immediate, so you have to specify it, or else you get this error every time. So serious pain now. So we're starting to get into the very painful area. But the most painful area we experienced, we were upgrading our database from 9.6 to 10. And the CPU just started to spike like crazy. I mean, it was just like 100%, 100%, 100%, almost all the time. And we got a whole bunch of people together. We're all trying to figure it out. We have Christoph's company helping us out. We've got AWS services helping us out. We have we have the enterprise package or whatever. So we got like immediate support in our Slack, and we're all trying to figure it out. We have no idea what's going on. And this went on for days. And then finally, we were like, well, we've eliminated this, we've eliminated that. Let's set the parameter group back to exactly what it was in the 9.6 parameter. Because, of course, we'd made improvements as we were upgrading, right? So we set it back using the source code control. We went and we found the previous version of the parameter group. And we set the Postgres 10 parameter group to be identical, 100%, every value the same as the 9.6 parameter. And that didn't help at all. So the next thing we did, eventually, I figured out, hey, I could look at what we are actually getting in the database. And so I connected to an old instance that had the old 9.6 parameter group. And I took a look at this particular parameter, max wall size, which we were pretty sure by now was something to do with wall that was spiking the CPU. And I looked at it, and the setting was 128, just like we had in the parameter group. And the units was 16 megabytes. And so then if you do show max wall size, it tells you, oh, it's 2 gigabytes. And you're like, okay, that's pretty good. That's not bad. That actually meant that we were checkpointing every 5 minutes or so. It's not too bad. But then we looked at it in Postgres 10. So exactly the same setting, family Postgres 10, went and looked in the database, max wall size set to 128 units, megabytes. So then if you ask for max wall size, you've only got 128 megabytes. So you've got 1/16 of what you thought you had. And instead of checkpointing every 5 minutes, you're checkpointing several times a minute. We went and back and looked at the AWS documentation because we're like, this is weird, what's going on here? And we looked, and it did not say anything about a change in the units. And we asked the AWS RDS people, and they're like, oh, yeah, that happened. And we're like, okay. And we're like, could you fix that documentation? And they said, oh, put in a ticket for it. We put in a ticket for it. We got a message back from them. They said, yeah, we'll update it that sometime in the next month. And we're like, yeah. We just spent, a dozen of our people a week trying to figure this out, all because you didn't make like a 2-word change to your documentation. So we reset it to actually be 2 gigabytes again in the Postgres 10 parameter group, and suddenly our problems were magically solved. And since then, actually, every time we have a CPU spiking problem, people are like, have we looked at max file size? Is it okay? At least we learned something. Okay, so you can imagine then, again, especially if you think about it as code, that you're going to be cutting and pasting a lot. You're going to be reusing a lot of things. We've got 34 database instances, so we're going to have to copy that AWS DB instance 34 times. And in the process of that, there's a lot of things that we're going to set to be the same. We always want our storage encrypted, let's say. We always want to use the same VPC. We always want to have backups at a similar time. Maybe, maybe not. But one thing that you can do in Terraform is you can create these modules. And so those are reusable blocks of code. It's really just like writing a function or a method. It has inputs and outputs. So what we do is we create this module, and it looks very similar, except that it says module and then the name of the module instead of resource, the type of resource, and the name of the resource. And then you use the module, you use the inputs and outputs to the module very similarly to how you would with any other resource in Terraform. But it gives you the ability to reuse the same code forever. So in this case, I make this RDS instance module, and I set it so that allocated storage is a variable, apply immediately is a variable, but storage encrypted is always set to true. So anybody who uses this module, they don't have the ability to set storage encrypted to anything but true. And that allows you to enforce any standards that you might have for creating your infrastructure resources. So I mentioned modules have inputs, which are variables, outputs. The inputs can have defaults, in which case they're optional, or they don't have defaults, in which case they're required. So they're reusable code blocks. They've got an API, but it's another abstraction. You've got this black box now. You're taking your HCL, you're putting it into this black box, and it's spitting out a bunch of resources. And you don't really know how that happened. I mean, it will show you in the plan what resources it's going to create, but you don't know why certain values are set the way they are if the module designer decided to do it. So what's really important in this case is that you define that API really clearly for people. So this is my big negative about Terraform, is that you've got all these layers of abstraction, right? So you're the engineer at the top. You're going through your Terraform config, which is one abstraction, probably through a module, which is another. You can have modules which reference modules infinitely. Do not recommend. It's like multiple recursion. You really only want to do one level. Then you have your parameter group, which is AWS's abstraction, and then RDS, which is another abstraction from AWS. So by the time you get to your server, you've gone through all these layers of abstraction, and any sort of magic could have occurred at any level. And so you really need to understand what's happening at every level, even though it's meant to make life easier for you. So in addition, you're going to have plan drift. I also mentioned minimal control structures. It's like a programming language, but it's not. If you think of HTML, it's kind of similar. So, for example, in our code base, we have these versioned modules, but we end up with all sorts of different versions. So each one of these is a release version of the module, but they're all different. And that means the API could have changed, the internal structure could have changed, we don't really know. And so the next time you go to update it, if you update it to the latest version, you might get more changes than you expect. In addition, people are able to make changes in the console. And if they make changes in the console, you're going to get plan drift again, and you're going to make a change, and you're going to plan, and you're going to be like, okay, I'm changing more than I thought I was going to change. So unless you completely lock down console changes, and unless you insist on modules always being consistent, you're going to get drift. Positives. You have a lot of consistency. So if you make the same HCL, you're going to get the same resources. If you make the same HCL in multiple environments, you're still going to get the same resources. You can parameterize this, so you can make smaller instances. You could not make so many replicas, but basically you're going to get the same structure that you asked for. Auditing. So this is part of our GitHub repo. We're approaching 5,000 pull requests. So that's 5,000 infrastructure changes that somebody actually took a look at, approved of, and then implemented on the AWS side. As opposed to before we had Terraform, there were probably tens of thousands of changes that were made, and we had no idea when, why, or who did it, other than by looking through AWS audits, which is not very good. The final pro is you have multiple providers. So it's not just AWS. I've been talking about AWS because that's what we use most of. But we use the Datadog provider. We use the GitHub provider. They have it for all different clouds. They say 200 plus more. I totally believe that. I haven't used all 200 of them, but I've looked at the list. So it's really nice because you can provision practically everything that you use. We started using Datadog extensively about a year ago to replace our monitoring and alerting, and we've been using the Datadog provider. We've also written our own provider, so we have our own CI/CD system for creating services and then testing and deploying them. And we've written a provider which allows people to specify their services within Terraform. So again, that allows us to specify our production infrastructure and then copy that to other environments without really having to know what was provisioned in those environments. We just have it recorded in the Terraform. So in conclusion, infrastructure as code, you have to do it. It's like, it has saved our lives so many times. It did screw us up that one time with the 9.6 to 10 parameter group, but on the other hand, at least we knew what we had and we could work from that, versus just sort of being like, well, I think it was set to this, and I'm not sure because we deleted it, so it's gone. Terraform I like. There are other solutions for this, but I find Terraform really easy to learn and reasonably easy to use. I mean, over time, you'll run into problems and you'll learn to solve them, but there's a great community. It's supported by a very good company. It is version 0.12 now, so they haven't actually had an official version yet, but they do a really good job maintaining it, and they do respond to issues. And finally, RDS. There are people at my company who argue that we should be self-hosting. We shouldn't be using RDS because so much is hidden from us and they want to be able to get their hands on it. But I'm one of the people who would have to update the software, do the backups, and make sure they had run correctly. I'd have to do the configuration directly in the database. I'd rather not. So my own feeling is that what we get from RDS is a lot more than what we lose, but that is really dependent on what kind of things you like to work on. The QR code is my LinkedIn, because one of my coworkers suggested that, but really there's only one Muffy Barkocy if you're interested in finding me, wherever you look. Any questions? Oh, lots of questions, okay. I'll start in the front and work my way around. Right. So he's asking if you've made a change in Terraform and AWS does something different, is there a way to compare to make sure you really got what you thought you had specified in the Terraform? We are working on some tooling to make sure that the Terraform plans do match what's in AWS. But if AWS makes a change like that, I mean, we kind of have to know about it before we looked for it. So we haven't. But we could certainly, I mean, so if you say, for example, that you know that your parameters or your settings are not what you thought they were, you could certainly write something to compare settings between two databases. In our case, I just did it, eyeballed it. Yes? In terms of managing the state? So best practices for managing Terraform state, the big one is that you use remote state. So it will store a state locally, which is what it thinks is out there, although it always goes and checks to see what's actually there when it's doing a plan. It doesn't just look at what the current state is. So that's one. The other one is that it doesn't really provide locking except locally. So you want to find a way to do remote locking, and that's one of the things that we use Atlantis for, but there are other tools that wrap around Terraform so that if I'm trying to make a change to a particular configuration and someone else is trying to make a change, it will stop us from both making a change. One of us will have to replan. Sure. Well, I'll move around and then come back. Yes. I cannot say why the company chose it because I was not in the infrastructure team at the time, but I'm sure we would choose it today after our experience with it. One of the reasons is we have a very active Terraform developer on our team now, so that gets us some good ability to make changes. But the other is that I really have had a good experience with it. I mean, all the problems aside, they make better stories. The problems make better stories, but really it's been pretty straightforward. Person in the back there? Right. So yeah. So the question is, the big benefits for Terraform come when it really does describe your infrastructure. So if people are making changes in the console, then it's not really describing your infrastructure. So you have to kind of lock it down. We're in the process of doing that now. We haven't finished quite terraforming everything, but we're starting to make changes to our security groups. We're starting to make changes to our roles so that really only the infrastructure team can work in the console, and then we try to be well behaved and not do it very often, and if we do, then we have to go back and make the changes in the Terraform. One of our projects for this quarter, oh boy, quarters, is that we're going to be making a comparison tool to tell us when it has drifted so that we'll be able to see that it did drift pretty quickly and then, you know, come down on the people who let it drift and then didn't update it so that people get better practices. Back to you. That was your question. Yeah. Yeah, so reverse engineering the changes that have been made is actually pretty easy with Terraform. There's two ways that you can do that. One is that Terraform has an import command, which allows you to import remote resources. And then once you've imported them into the state, then it will show you the difference between your Terraform and what you want to, what is actually out there in the world. So it's a lot of back and forth. But it's a lot like, again, it's kind of black box. So if you had a piece of code and you gave it certain inputs and you got certain outputs and you were trying to replicate that code, you just keep giving it the same inputs and make sure you get the same outputs, and eventually it matches up, right? So a lot of it is experience. Once you've had some experience using Terraform, it's pretty easy to make it sync up. And then the other is just trial and error. Yeah. Yes.
And I remember trying to use Terraform to spin up a new RDS instance, and that password is the master password.
Yep.
I'm aware of HashiCorp Vault, but that's obviously a pretty heavy abstraction. Is there any
Yeah. So it's funny because when I gave this talk at my office, our security team, that was their first question. So it did show a password field, and I set the password. And you do, when you're creating a new instance, you do have to set the password in the Terraform. However, and I didn't point this out, but it does mark it as sensitive in the output from the plan. And then subsequently, it shows it as sensitive. It never shows it. So it never displays it in the plan. It's only in the Terraform file. So that's still bad, right? So the way I made our RDS instance module, it sets the password to I am a bad password and tells people that they should then go into the console, change it, and put it into 1Password, which is where we store, we have a database super users vault where we store the passwords. In terms of HashiCorp Vault, that won't help. That is where we store a lot of our other sensitive information, but it's just a quirk of RDS that you absolutely have to specify that super user password when you're creating the database. So you just have to go change it afterwards, and you have to have good practices on that. Yeah? You can pass it as a variable on the command line. The drawback to that is that it's not we go through this thing called Atlantis, which is a GitHub thing, and so you would end up writing it out in the clear on there. So it would only be doable by certain members of the team. But yes, you could do that. You can specify any variable to Terraform on your command line, and then it would only be there for however long your shell was up. Other questions? Yeah. Yeah, so have we tried Terraform plan diff tools? In the past, yes. When we were using version 11 and below, all the versions below 12, there is actually a thing, I think it's just called Terraform diff. But the new Terraform version 12, does a pretty good job of showing you the diffs. The parameter groups are still broken, and I may actually get inspired at some point to write something to make that work better, and then maybe submit it to those guys. But for the most part, it shows diffs really well now, and it also shows the output in HCL format, where it used to be more of just text. And so it makes it a lot easier, which is also one thing that makes it easier when you have had drift and you need to update it, because you can just cut and paste the HCL that it spits out. But yeah, there's also another tool that hasn't been updated for version 12, but it's really nice for modules, which produces docs, which produces API docs based on the variables and outputs. So I hope someone updates that soon, because when you have something like an RDS instance module, you've got about 30 to 40 inputs and a dozen outputs, and it's much easier if you can automate that. So yeah, there are a lot of tools. There's a good community. More questions in back? Do we have tests? I would love to have tests. I've just, if you could look at my browser tabs, I've got a couple tabs open on doing tests for this. But no, right now we don't, and I'm not really sure how to write them yet. I haven't found a good way. One thing that we do have is in GitHub, we have a bunch of actions which occur before we'll approve a pull request. And so I'm thinking of adding a bunch of, like, essentially the equivalent of like a linter to there to look for things that we know are bad and say, hey, don't do that. So that, again, that's part of our project for this quarter, now that we've got our Terraform pretty much under control, is to make it a lot cleaner and a lot more informative to people when they're making mistakes. More questions? Yes?
What happens if I have our instant delete protection turned on, and when you do Terraform watch?
Yeah, so if you have delete protection turned on in AWS, then you'll get a message back from AWS. So again, Terraform will allow you to plan and apply, because it doesn't know that. And then it will tell you, oh, I can't delete this. You can also turn on delete protection within Terraform. There's a code block called lifecycle, and you can do prevent destroy. You can also do some other things there, like ignoring certain changes, or saying, okay, you have to create new resources before you destroy old resources for like blue-green deploys, that kind of thing. So yeah, it will always honor the prevent destroy, but what I find is that can make things a lot more difficult, because there are times when you want to make a plan and you want to make changes, and it will simply say you can't destroy this resource instead of showing you why it was trying to destroy the resource. So then you have to turn the prevent destroy off. So I generally would do that through some sort of permissions in AWS rather than setting the explicit prevent destroy, because that can make it very difficult to use Terraform. Yeah, once you've got it the way you want it, then I would turn it on. And apparently I'm out of time, but find me later if y'all have more questions. Thanks, guys.